Welcome. So I have secant to the fourth of x minus the tangent of fourth of x. And when factoring trigonometric expressions, what I like to do is I like to rewrite them as not with trigonometric terms. So let's just do an x and a y. So I have x to the fourth minus y to the fourth. And what I notice is my powers are both going to be are square numbers, and that's really important because when I look at a square number minus another square number, what I notice is I can always apply the difference of two squares. So the difference of two squares, remember, says a squared minus b squared can be refactored as a minus b times a plus b. So if I'm going to look at this, what we need to do is determine our a. So I said these are square numbers, so what is going to be my a? Well, therefore, that means I can rewrite this as x squared squared minus y squared squared. Therefore, my a is equal to x squared, and my b is equal to y squared. So by rewriting this, I can now say that I can say x squared minus y squared times x squared plus y squared. All right, so that's now kind of fine and dandy, but what do you do with your trigonometric identities? Well, let's just go back through it and remember, well, instead of using x to the fourth, I'm using secant to the fourth. So therefore, I can just replace the secant with the x and the tangent with the y. Therefore, leaving me with secant squared of x minus the tangent squared of x times the secant squared of x plus the tangent squared of x. Okay. Whew. All right, so these are two nice big binomials multiplied by each other. Now, what I can do is I want to see, all right, can I simplify this any further, right? Because I know it goes back to here. Well, remember, secant and tangent are both part of the same, they're both part of the same Pythagorean identity, which states that 1 plus tangent squared is equal to secant squared of x. And that's really important because I notice I have secant and tangent squared. So what I'm going to do is I'm just going to kind of pick one of these values to plug in. And since already in the identity I have secant squared solved, I'm going to plug wherever I see a secant squared of x, I'm going to plug that in for 1 plus tangent squared. So over here I have secant squared of x, which now I'm going to rewrite as 1 plus tangent squared of x. And then that's minus tangent squared of x times, again, another secant squared of x. So I'll do 1 plus tangent squared of x plus tangent squared of x. OK, so now let's simplify inside each one of my parentheses. Well, I don't really need, there's another parenthesis there. OK, and there'd be another parenthesis there. All right, well, I don't really need my parentheses to simplify because I can simply say tangent squared of x minus tangent squared of x is going to be 0. 0 plus 1 is just going to leave me with 1. And then here I have 1 plus tangent squared of x plus tangent squared of x is going to give me 2 tangent squared of x times 1 plus 2 tangent squared of x. Now, this isn't going to be another Pythagorean identity, so I can't simplify this any further. But my final answer is just going to be 1 plus 2 tangent squared of x. So there you go, ladies and gentlemen. That's how you simplify trigonometric expression using the difference of two squares. Thanks.